This example is about scientific notation. The first example, it says, write each number in scientific notation. These numbers you can see, A through D, those are given in standard form, so we want to change them to scientific notation. Alright, scientific notation consists of a number between 1 and 10, excluding 10, but can be 1, and then times 10 to raise to a power. So if you look at this first one, it's a small decimal number, so we know that the exponent on 10 is going to be negative. And what you do is you write down those non-zero digits, the 4 and the 5. You place the decimal point right after that first non-zero digit. So it makes it 4.5. That forces that number to be between 1 and 10. Alright, so it's 4.5 times 10. All we have to do is count. That decimal point is here. I'll move 1, 2, 3, 4 places. And it's negative because it was a small decimal number to begin with. Alright, we move that decimal 4 places. 1, 2, 3, 4. Right. So it is now between 4 and 5. Okay, let's look at part B. Part B, that's 12 million. So the non-zero digits are the 1 and the 2. So we're going to make it 1.2 times 10. My decimal points here. So 1, 2, 3, 4, 5, 6, 7. Positive. 7 positive isn't a large number. It's not a small decimal number. Right? Similar to part C, that's just a 9. The only non-zero digit there is 9. So you don't even have to use a decimal point. That's already between 1 and 10. Times 10 to the, let's see how many decimal places this is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yikes. 10 to the 11th. Right, it's a large number. And part D, again, this is a decimal number, small decimal number, so the exponent on 10 will be negative. We say the non-zero digits, but if there's a 0 in between there, we need to have all those in there. It's actually going to be 6.701, like that. Alright, again, you can just write down those digits, 6701. Make sure you place your decimal point right after that first non-zero digit. Alright, 6.701 times 10 to the negative, let's see, 1, 2, 3, 4, 5, 6, negative 6, just like that. 3, 4, 5, 6, good. Alright, so converting a number from standard form to scientific notation is not tough. Just remember, your exponent on the 10 will be positive if it's like a pretty large number to begin with, like parts B and C. If it's a small decimal number, like A and D, that exponent is going to be negative on the 10. Alright, so let's look at that next example. It says convert each number from scientific notation to standard form. Right, so these numbers will either be like large numbers or they'll be small decimal numbers. These are pretty easy because, look at part A, 2.39 times 10 to the positive 6. Since it's positive, you see the decimals already between the 2 and the 3. What we have to do, it's positive, so you want it to get a large number, you're going to move that decimal to the right. Alright, let's just write those numbers down. The 2, the 3, and the 9. Alright, the decimal started here, so I need to move it 6 to the right. 1, 2 is to the right of the 9. 1, 2, 3, 4, 5, 6. Alright, just like that. Again, this one, if it's positive, you want a large number, so you're going to move it to the right. If the exponent is negative, you want a small decimal number, you're going to move your decimal to the left. That many places. Alright, let's look at 4.6 times 10 to the negative 4. Negative means I have to move it to the left. So 1 will be in front of the 4. 1, 2, 3, 4. Alright, I need 3 zeros out there. Not including that one. 1, 2, 3. The 4 and the 6 stay there. Alright, it started off between the 4 and the 6, and we moved it left 1, 2, 3, 4 places, just like that. Alright, let's do part C the same way. The decimal point for just an integer comes after, it's to the right of the 3. Right, so we have to move it back -8. Alright. 1 is just going to be to the left of the 3, and I need to go 7 more. So let's put 7 zeros out here. 1, 2, 3, 4, 5, 6, 7, and my 3. You can always double check it by counting to see if we moved it right. It started over there for the 3. 1, 2, 3, 4, 5, 6, 7, 8. So that was right. Alright, small decimal number, we moved it to the left. Alright, part D should be a large number. If you see the first part of scientific notation, 5.5001, doesn't matter how many decimal places come after your decimal point. I still have to move that decimal 9 places to the right. 1, 2, 3, 4. Be in front of the 1. Let me write all those digits down. 5, 5, 0, 0, 1. Alright, so it started here, 5.5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just like that. Alright, so it's not rocket science. Scientific notation. A lot of students have seen it before. Maybe they haven't done the conversions, but that's how you do it.